Now, an exterior angle is just an angle that's formed by extending any one side of the triangle. I'm going to show you a bunch of examples of that in just a second, but just know that this angle right here is known as an exterior angle. That is an exterior angle. Well, an exterior angle always equals the sum of the two non-adjacent interior angles. Those two angles are right here. So basically, 2 plus 3 equals 1. Probably not good if you're an algebra teacher saying that. But in this case, 2 plus 3 equals 1. I'm talking about the angle. So here it says measure of angle 1. Well, measure of angle 1 would equal the measure of angle 2 plus the measure of angle 3. Now, I'm going to talk about exterior angles really quick. There's actually 6 different exterior angles you could draw for a triangle. So we don't need to write this down. I just want you to pay attention. I'm going to erase some stuff. And I'm going to draw some stuff. So if I extended this line going this way, different than how yours is extended, right? I extended another side. This would be our exterior angle. It's the one formed by the triangle and the line being extended. These would also be the ones I'd add up to equal it because they're not adjacent to it. Now, let's look somewhere else. Let's say I extended this line here. My exterior angle would be here. But do you see how 3 is adjacent to it? Guys, do you see how 3 is adjacent to this? Because you have to look up here for me to know what I'm talking about. 3 is adjacent to it, so that would not be the one you would add together. Instead, you would add kind of, let's say we had 2 and 4. These two would add together to equal that 1. It has to be out of the mix. Because if it's in the mix, it's just a linear pair. And they have to add to 180. And it wouldn't make sense to have something that adds to 180 always equals the other thing. Okay, so it's always the one that's out of the two angles that are out of the mix. So we're at 1, 3 is a linear pair. I'm not going to use that one. These are actually called remote interior angles. A lot of times they're called that because they're remote from our exterior angle, but they're still interior. So that's another name for those. So if anyone asked you for these names, we could call them remote interiors. I am not requiring you to memorize that word. Remote interior angles. I'm not going to have a problem that says make sure you draw the remote interior angles. I'm just going to talk about the exterior angle and ask what it sums to, okay? So, good geometric word, you're not responsible for knowing it.
On a test, if it asks us like what theorem is this problem, and we write remote
Interior angle sum?
interior angle, will we get extra points?
Sure. I don't see that happening because we're not going to have proofs in this section. That's why we're not going to get a pink sheet. But if you wanted to earn some extra credit, maybe on a problem like this, you can say, I know those are called remote interior angles. Because that'd be something, right? You're telling me a little extra information that you weren't required to. I can always give us points for that. All right, that's it. That's our whole lesson.
Cool.
But with the lesson comes, we're going to go through some problems together. So if we know those two rules, we can do everything on here. In fact, I'd venture to say a few of us could actually do a bunch of these without me walking through it, but the class is for everyone, right? So we're going to go through a bunch together to make sure you understand the flow of how to do a problem like this. So we're going to start out real easy. We have a triangle. How many angles do I know of that triangle for a fact? I know 2 of them, right? I know 1 is 37. I know 24. If you ever know 2 angles of a triangle, you know the third angle. Because to get to that third angle, we know that this plus this equals 180, right? So if I'm ever missing an angle, all I'm going to say is, okay, the sum of all these equals 180. But I've already used 24 up, right? 24 of those degrees are used up, so I'm going to subtract 24. Then I'm going to subtract 37. So I have 180 to distribute between them. I've already used up 24 degrees and 37 degrees. And now we're just going to take out our calculators if we don't know how to do this right off bat. And I need 180 minus 24 minus 37. And we all need to be doing it because I'm not just going to take one person's answer for it. I'm doing 180 minus 24 minus 37. 119. Did anyone else get 119? We're looking good at 119, so we're going to have 119 degrees. Hey guys, I have two ways to do this one. The easy way is to know the remote interior angle sum idea, or our exterior angle theorem. And that says this angle equals these two added together. So all we need to do is do 76 plus 52, which is maybe 128. Maybe. 128? I got a yes? Yes. All right, we have 128 degrees. Now remember I said there's two ways to do this problem? Let's say I forgot this theorem. This is what I do. How many angles do I know in this triangle? I know two. Can we always get a third? I would find the third and go, oh, that's a linear pair. That would have to add to 180. So I could find this angle and know that the linear pair adds to 180. It's more steps, but it is doable. All right, for our next one. Once again, an exterior angle 104 equals those two remote interior angles added together. So that means 104 equals the measure of angle 1 plus the 79 degrees. Well, I need to get the measure of angle 1 alone, so that just means I'm just going to subtract 79 from both sides. So I'm going to go ahead and I'm going to subtract 79 from both sides. Minus 79. And I have 104 minus 79, which equals... It doesn't equal 30. 104 minus 79 is 25. 25 degrees. So we put 25 degrees here. Once again, there's another way you could have done this one. 104 and the angle next to it are a linear pair. So the angle I'm pointing at right here would have to be 76 degrees. And then I could use that 76 and the 79 to find that missing angle 1. So there's two ways that we could handle those problems. Either remember the rule where they add up, or we can go ahead and do the linear pair and do it that way. Okay, now we get to the more difficult stuff. When I'm doing any one of these problems, I'm going to locate any triangle where I know two angles of that triangle. So I'm looking at this particular triangle right here. I have one angle being 66 and I have one angle being 84. Can someone, let's make sure we're taking all of the notes. Can someone walk me through how to find a missing angle if I know two angles of a triangle? Yeah, Austin.
You add them together, then subtract them 180.
Yeah, we can do 180, and I wouldn't do it that way just because I'm plugging in my calculator. So in my calculator, this is same idea, right? But just if I have a calculator, which we should, I'm always just going to go, well, that's just 180 minus 66 minus 84. It just makes it a little easier calculator-wise. If I was doing it by hand or something, I'd probably add it and then subtract it, or if I'm trying to do it in my head. But if I'm using my calculator, I'm just going to go 180 minus minus. It's just a quicker way to use our calculator. Now, what happens if I do 180 minus 66 minus 84? What do I get out? 30? So 1 is going to be 30 degrees. How do I get one of the other two angles? How do I get either one of the other two angles?
You can use, well, for the 3, you can use the linear pair theorem.
Sure. Do you see this 84 degrees and this 3? Do you see how they make a straight line? That means they have to equal 180 degrees. So anytime we have a straight line, we should start realizing that, oh my God, that's always 180 degrees. So if I want to find angle 3, I'm just going to do 180 minus that 84. So angle 3 is just going to be the 180 minus the 84, which should have equaled 96 degrees. So we have 3 being 96 degrees. And then how do we get to 2 then?
2?
Yep. Make sure we're not working too far ahead, otherwise I'll take our sheets away because I need help. I need help going through these. So make sure you're staying with the class.
So you add up the 90, well, you do 180 minus 96 minus 43.
Do we see that? How many angles do we know from that triangle? Is it just one guy doing all the work?
No.
No? How many angles do I know from this triangle here?
2.
2. And anytime we know 2 angles, we should be able to find that third angle by doing what Austin said. That we're just going to take 180 minus the 2 known angles. So to get to angle 2, we're going to say, okay, it's a triangle, so it equals 180. We're going to subtract the 2 known angles, so I'm going to subtract a 96 degrees. And I'm going to subtract a 43 degrees. What do we get out if I do 180 minus 96 minus 43? Yeah.
How'd you get 43?
I got it. They gave it to me.
Oh.
Yeah, they gave me the 43. I didn't actually calculate that. I just said, okay, this triangle here,
41.
we found the 96 and the 43. So you're saying 41 degrees?
Yeah, 41.
Do people agree with 41 degrees?
Yeah.
Yeah, okay. We're good over here? So we have 41 degrees. So that's going to equal 41 degrees. Our next one. We got multiple triangles we can draw once again. I'm looking at this triangle here. How many angles do I know from that triangle, that orange triangle?
You know 2.
I know 2 because what's the measure if it's a box? 90 degrees. So we have a 90 degrees and a 43 degrees. How do I calculate that missing angle, people? So we have angle 1 is going to be 180 minus 90, because that box is a 90 degrees, minus 43. I believe that comes out to 56 degrees? 47. Oh, I was way off. So we should have 47 degrees. Thank you for checking my math. 47 degrees. Now what? We have lots of different stuff we could do.
You can do the linear pair theorem to get 2.
We could do linear pair to get to 2. That'd be a good way to go. What else could we do?
You could also
I'm going to draw a picture real quick. Now, I'm going to do the linear pair because that makes sense to do that next. But I'm going to draw a different picture for you, something else we could have done too. And we're going to have to do too. Do you see that red triangle I drew? We know this is 90, right? Don't we know this angle too, this whole thing?
yeah, it's
Because we know one is 47, and we know this one's 12. So this whole angle right here is going to be 12 plus 47. So this whole angle right here is 12 plus 47, which would equal 59 degrees. What was that?
Oh, I was looking at that and you did that.
Oh, sorry. Does that make sense here then? Okay, yeah. So I'm just saying we know one, we know this one, that's 59 degrees. Now I know two of the angles of this triangle. So anytime I know two angles of a triangle, we just do 180 minus those two angles that I know. So to get to angle 3, we're going to do 180 minus the 59 minus the 90 degrees.
Oh.
Do you see that?
Yeah.
You'd have to know how to do that one. You have to understand that we have a big triangle there and we know two of the angles. And I believe that should be 41 degrees. It's 31. Thank you. It is 31 degrees for people checking my math at home. So 3 is 31 degrees. And then, Austin, you told me we can get the angle 2 because that's a linear pair. Yeah. Yep. So let's go ahead and do that. So I'm looking at here. This is a linear pair. So to get to 2, we're just going to do 180 minus 43. 137 is correct. Now, I'm going to talk about another way we could have got 2. It's something we learned today. We just learned it today. 2 is actually an exterior angle. It's also the other triangle. I have to erase a bunch for us to picture what I'm talking about. But if I look at this angle here, 2 is an exterior angle. So 2 should actually be the sum of 1 plus the 90. 1 was 47. This was 90, which equals 137. So we could have used that exterior angle as well. Okay? So a couple things we're learning. Big thing are linear pairs. Understand that we have multiple triangles. And now we're going to institute some math facts that you need to know from geometry. Do you see that 61 degrees that's hanging there? If you don't know what to do with that 61 degrees, you're going to have problems solving a lot of these problems. It is vertical angles. It is vertical angles. You need to start seeing vertical angles. We talk about it all the time. We have vertical angles between that 61 degrees and that 2. So 2 has to be 61 degrees. I would do that before I do anything else. I'm going to look for vertical angles and certain things. That's just 61 degrees. That is just me asking, do you know what vertical angles are? Without me asking. Now this problem is really easy because we have 2 angles from every triangle, right? If we look at the top triangle, we have a 61, a 68. The bottom triangle is a 61 and a 90, which means we need to find missing angles. I'm going to go ahead and find angle 1 if I know it's 68 and 61 here.
You add them and subtract 180.
Yep. So we add them together and we go 180 minus it. Like I said, if we're using our calculators, I'm more or less probably just going to take 180 minus 61 minus 68. What does that come out to? 51. Did anyone else get 51? 51. Actually, real quick, we're going to do the same thing Lacey kind of talked about, where we're going to do that 180 minus the 61 minus the 90. So we'll do 180 minus 61 minus that 90. Check my math. Did you get out 29? 29 degrees is correct. All right, so that one I have to know what vertical angles are. For the next one, you have to know what the term bisect means. I know we talked about bisect cutting in half, right? Yeah. But more specifically, as it cuts in half, it creates 2 congruent angles. So when I see the word bisect, we think 2 congruent angles. 2 and 3 would be 45. Correct, because if I look at what's happening, we have BC bisecting ACD. So if I highlight ACD, and if BC bisects it, that means 2 and 3 are equal to each other. The only way they're equal to each other is if they're both 45 degrees. So we could put a congruent symbol, or more likely I'm going to put a 45 degrees of 45 degrees. So 2 and 3, 45 degrees. And guess what? If this problem's on the test, you have half it done just by knowing what the word bisect means. Which at this stage, if you don't know what vertical angles or bisect means, you're purposely not learning this material because we use it consistently. Vertical angles are just across from each other. Bisect means cut into two congruent angles. All right, that means that we have two triangles where I'm just missing a bit of information from each of them. So I'm looking, how do I find, how you'd find angle 1 right now?
Add 45 and 48, and then subtract by 180.
Okay, but if I was using my calculator, I would do 180 minus 48 minus 45. Let's be as efficient as possible that we're not typing something in and then having to type it in again. We just do 180 minus 48 minus 45. What do we come up with? Let's go this pod. 153. 143. Okay. Yeah, that seems a little big, right?
87.
87. Back pod, do you agree with 87 degrees for that one? Okay, cool. To figure out 4, we're going to do the same thing. I got 180 minus 45 minus 83. Front pod, what do we get if we do that math? $52. Left pod, do you agree with 52 degrees? Okay. Then we got that one done. So, big things are multiple triangles. Make sure you know what vertical angles are. Know how to use bisectors. Also, we have to keep track of linear pairs. All right. Number 8. Number 8's actually just, it's just there to make it look complicated, and it really isn't a complicated problem. How many triangles do you see up there? We have 2 triangles. How many angles do we know of both those triangles? 2. 2 from each, right? Total of 4, right? Yeah. So if I ever know 2 angles, we know how to find the third one, right? So I'm looking for, how do I find angle 1? Lacey, okay? Okay. And you said it my way too. So we're doing 180 minus 41 minus 75. Can someone from the back pod tell me what that equals?
Which one?
The one I just talked about.
64.
64? So 1 is 64. Can another person confirm that 64 degrees is correct?
64.
All right, 64. Let's go. For 3, we do the same thing, right? We do the 180 minus the 2 things that we know. So to get to 3, we're going to do 180 minus 90 minus 54. I think that would be 36 degrees. Can you guys confirm my 36 degrees? Cool. All right, so if this one's on the test, we got 2 easy ones, right? We have 2 that should just be knock out of the park and get it. The only really hard one is 2. How do we get 2? I'm going to help out, but I'm actually going to put in that angle 1 equals 64 degrees because that's important.
Is that 90?
That is 90. Yep. How do I find angle 2?
Oh, how do you?
Yeah. Aaron?
90 plus 64 minus 180.
Yes. And the reason why he said that is because you saw that a straight line equals 180 degrees. A straight line always makes 180 degrees. So that means 64 plus 2 plus 90 has to equal 180 degrees. So we're going to do kind of the same thing we did with triangles. We're going to start with 180 degrees because that's a linear pair. We're going to subtract away the 90. We're going to subtract away that 64. And the remainder is going to be angle 2, which should be 26. Question mark?
26. Yeah.
26? We're good with 26?
Yeah. Yes.
You sure? Okay. So 26 degrees. All right, so this one was easy except for one big fact. A straight line equals 180 degrees. So every one of these has like a small trick in them, right? We just have to find that trick. But do not just pick the hardest angle to find. Find the easy stuff first. This one has to do with what we just learned. Not today, but on the test. Do you notice up here it says L is parallel to M? So you need to make sure you understand that these are parallel lines. I'm going to highlight them. With parallel lines come transversals. I'm going to highlight one transversal that's really important right now. What kind of angles are 1 and 73?
Alternate.
Yep.
Interior.
Alternate interior. What do we know about alternate interior angles?
They are
Congruent. Yeah, because the only ones that are supplementary are same side. We're not going to be dealing too much with same sides. We're going to be dealing with angles that are, in fact, congruent. So 73 and angle 1 are congruent. So angle 1 is going to be 73 degrees.
Angle 4 and 49 are also congruent.
Angle what?
Angle 4 and the
49 will also be alternate interior angles, because let's highlight those lines that we're talking about here. So my transversals here, once again, these are my parallel lines. We're going to note that 4 and 49 are alternate interior angles. So 49 is also, let's put 2 tabs on there. So 4 is also 49 degrees because they're alternate interior angles. So 4 is 49 degrees. That should be the big trick on this one. Now, I want us to look at 4 and 5. What kind of angles are 4 and 5? And if you don't know the name, who cares? You just need to know what they add to. So let's go over, does anyone know the name of 4 and 5?
linear pair.
Linear pair. What do they add to?
180.
They add to 180. That's the big thing, right? I'm not going to ask you, make sure you support. We're not doing any proofs on here. You just need to know straight line, 180 degrees. So to get to 5, we're just going to start with 180. And we're going to subtract away the 49. Does that make sense? Because those two things added together equal 180. So subtract away the 49. And we should have 131. So 131 for angle 5. Hate to put you on the spot. If you have questions, ask me. It's basically the same problem. How do I find angle 3 then? Using the same idea we did here. $73. You got it. Yeah, that's all we have to do. That these two things are a linear pair, so they add to 180. So to find one that's right next to it, we just need to do 180 minus 73 degrees. 180 minus 73 degrees should be 107 degrees. So 3 is 107 degrees. I have 2 ways that I can think of getting to angle 2. Can anyone help me out with a way to get to angle 2? Lacey?
with the never mind.
You sure? Okay. Anyone else have an idea how to get to it? Yeah. Alternate interior are actually not going to work for... maybe. How are we going to use alternate interior? With 3? Kind of. So 3 and this whole thing would be alternate interior. So we'd have to subtract away 49. It would work as long as you subtract 49. I'm looking for one where I don't have to worry about subtracting those. So it would work. Do you understand how it would work? Okay, Austin, what can I do without...
You would take the measure of angle 1 plus 49 and subtract about 180.
Yeah, so what I think you're saying is we have a straight line here that equals 180 degrees. So we'll do 180 minus 79 minus 49. The other way that I would think about this is we have a triangle here that I know two of the angles.
So you can do 73 plus 49.
Well, it's the same numbers, right?
Yeah.
Both ways, no matter which method we use, is going to turn out to being 2 is just 180 minus the 79 minus the 49. Yeah. I don't know. Did you get my sum for this yet? 52? Do you agree with 52? Yeah. 52? Uh-oh. I would go with 52, I think. It's 52. Lacey, make sure we're not just putting those numbers down. I'm putting a lot of work up there, right? I'm not doing it for my health. I know how to do these. I know you guys are just testing to see if I know how to do them. But these are the marks that we kind of need to practice in our head. Okay, good. All right, our next one. Hey, do easy stuff first. Yeah, go. Do easy stuff first. Don't find the most complicated number you can find. What I'm going to do is I'm going to locate a triangle where I know two of the angles. And I actually see two kind of ones that I start with. I'm going to start with this one here. Because I have a 90-degree angle and a 52-degree angle. 3 with what I just talked about. Take your time. We would do 45.
45. Angle 3 would be 45. Are you asking for like the whole thing?
I don't think it's 45. No, I'm just... So, notice this triangle I highlighted?
Yeah.
How many angles do I know of that triangle? One. What about this one?
Oh, right angle, my bad.
Yeah. So now how would I find 3? If I know two of the angles.
So it'd be 180.
180.
Minus 90.
There we go. Now we're on the track. 180 minus 90 minus 52. Yes. So our angle 3 should just be 38 degrees. 38 degrees. 3 is 38 degrees. Okay, does anyone see how I'd get angle 6?
Yes. 90 minus 52.
Gentlemen? Can we stop? If we can't stay with the class, then we'll lose our sheets and I'll force us to stay with us. All right, so I have a 90 degrees right here, right? We know part of it's taken away by the 52, so we're just going to do 90 minus 52, and that's going to give me my angle 6. So my angle 6 is just 90 minus 52, which is going to equal 38 degrees. So 6 is 38 degrees.
So I know,
You know that one?
right?
And we also know this one, right?
Oh, right. Sorry.
No, you're okay.
So I could go 180
180 minus,
minus 38 minus 86.
perfect. And what do we get out if we do all that?
Uh,
56? Did anyone else get 56 on that one? Yeah? Okay. So now we have 56 degrees. Now remember what he did was he did 180 minus the 86 minus the 38 gave him a 56 degrees. Which number did I just cover up? 5? All right, so that's 56 degrees. Now someone besides Austin, because it's kind of the exact same idea as he used. How do I get angle 1 now? Yeah, Alan. 90 minus 56. Perfect, because we know the whole thing's 90. We have part of it's 56. So 90 minus 56 is 34 degrees. So this is going to be 34 degrees for angle 1. Yeah, Alan. Yeah. And now we're going to use the exact same idea to get to angle 2. To get to angle 2, we know a chunk of it's 38. The whole thing equals 90. So I'll do 90 minus 38. Does that make sense? We're good with that? Okay, what's 90 minus 38? 52 degrees is correct. So 2 is 52 degrees. To get to 4, I can see two ways to do this. Do you see how 86 and 4 are a linear pair? It's probably what I would choose to do, but we could also realize that this is a triangle. So I could also do 180 minus 52 minus 34. Whichever way makes more sense to you. You have a calculator, so either one will be just kind of as easy. So I'm going to go ahead and use that 86 and 4 are a linear pair. So that's 180 minus 86, which should be 94 degrees. All right, I'm going to kind of push through on the next one, okay? Because I really want to get to some other ones. So make sure you're paying attention with me. We have two parallel lines. We have two parallel lines. I'm highlighting them. We also have transversals. And the transversal I want us to really focus on is this one here. And I want to focus on that one because do you see how the blue and red line form 47 degrees? If I follow that all the way down to angle 7, those are alternate interior angles because this one's also formed by that blue and the red. So that means 47 is the exact same thing as number 7. So these two things are congruent to each other. Let's highlight it in greenish. So 7 and 47 are congruent to each other. So now I have 47 degrees for 7. We got some triangles in here, but I want to focus on this 71. This 71 is going to be used to get 3, 2, and 5. What do we notice about 71 and angle 2?
They're vertical.
They're vertical, so they are congruent. So if they're straight across, they're congruent to each other. So 2 is 71 degrees. 2 is 71 degrees because they're vertical angles. What do you notice about 71 and the angle 5?
They're linear pairs.
They're a linear pair, so more importantly, what do they add to?
180.
180. So 71 plus something equals 180. We're doing 180 minus that 71, which will be 109. And then we can use the vertical angle to get to 3. So 3 and 5 are both 109. I'm going to stop there. And the only reason I'm going to stop here is, do you see how everything else is just triangles with two angles?
Yeah.
We should know how to do that. I just want to push on, okay? Do you think we could finish that one? Are you guys okay? I got triangles with two angles. Okay. Because I definitely want to get 2 of these done so you can do 2 of them. Show me you can do them. All right. Very first thing we learned today, we learned that 3 angles of a triangle add up to 180 degrees. Okay, so on a problem like this, I know angle plus angle plus angle equals 180 degrees. I need to set up an equation to solve for this. So my equation is just going to be plus equals 180 degrees. So let's go ahead and set that up. It doesn't matter what order you put them in because all 3 of them just have to go up. I'm going to start with 9x plus 3 because it's on top, no other reason. Plus, I guess, the 11x minus 21 plus 5x minus 2 equals 180. The rest is just an exercise in knowing how to do your algebra. Now, remember, when you're solving algebraic stuff, do not do anything until both your sides are simplified. That means you combined all the like terms. So if I look on the left-hand side, I have a 9x, an 11x, and a 5x. Those all can be combined because they both have, all three of them have an x attached to them. So that means in your calculator, you're really just doing 9 plus 11 plus 5, which should be 25x. The rest are just numbers that we're going to add together. So notice how we have a positive 3, a negative 21, and a negative 2. We're really just going to take 3 minus 21 minus 2, which should equal a negative 20 if done correctly. And that should equal 180. So before you do anything, make sure your side is completely simplified. Now, to solve for x, you're going to move everything that's not an x. So that's that 20. See how we have a negative 20? What's the opposite of a negative 20? A positive 20. So we're going to add 20. Now, be careful because I see people where they do this. It's not how it works. It's got to be on the other side of the equal sign. So what you need to picture is kind of this wall here that if I have a plus 20, it has to go to the other side of the wall. So we're going to add 20 over here. That's going to give me, that's going to cancel that negative 20 and 20 cancel out, which is going to give me 25x equals 200. Notice how that 25 is attached to that x through multiplication. What's the opposite of multiplication? Division. So we're going to divide by 25. The whole reason we're dividing by 25 is so those 25s cancel out. We still have an x. We'll divide this by 25. And so we should have just 1x equals 8. Now, I was pretty nice on these problems. I try to set it up like this so you know you didn't finish the problem. Because I said I need x, d, e, and f, right? So now we know what x equals 8. How do I find the angles then?
You find the angles by plugging in x for each one of the angles.
You plug in your x value for each. Remember, all a variable is just something. This says 5 times something minus 2. I found out that something is 8. So rather than 5 times something minus 2, this is 5 times 8 minus 2. So this right here is no longer 5 times x minus 2. It's 5 times 8 minus 2. And 5 times 8 is 40 minus 2 is 38 degrees. Instead of 9x plus 3, we're going to replace the x with 8. So now we have 9 times 8 plus 3. Well, 9 times 8 is 72. Plus 3 is going to equal 75 degrees. And our final one, instead of 11 times x, we're going to do 11 times 8. So we're going to plug an 8 in here. 11 times 8 is 88. Minus 21 is going to be 67. Did I do that right? My brain feels fuzzy today. 88 minus 21 is...
It should be 78.
67.
It should be 67. So we have angle D equals 38. We have angle, I can't read them anymore. F is 67. And so our last one should be 75. Okay, I'm going to skip number 13. You guys are going to do number 13 because it's basically the same problem. Just show me that you know how to do it. We're going to go ahead and we're going to jump to number 14. Number 14, this is probably the only time you absolutely have to know this rule. Exterior angle equals your two angles that are not adjacent. There's no other way to do this problem. Every other problem, you can work around it. This is the only type of problem where you have to know this rule. So this rule says your exterior angle equals these two added together. So that's our equation. our equation has to be 18x minus 15 equals 13x minus 1 plus that 4x plus 1. Exterior equals these two angles added up. Go.
It's not 1, it's 11 for 13.
Oh, thank you so much. That could have been a long road and found out it's wrong. Yes. Thank you.
No.
You good, Austin?
No, I just had my order reversed.
Okay. Yeah, it doesn't matter. You could have flipped it as well.
Oh, okay.
Just make sure you have these two added and it equals this. You might have had it flipped where you had the 2 over here, or you might have these flipped as well. All right, as long as you have the same numbers on that correct side. Now remember, when you are solving algebraic equations, you always simplify the sides first. So think about this as being two different sides of an equation. My left-hand side is as simplified as you can get. It just stays 18x minus 15. The other side is not simplified because we do have a 13x and a 4x. You can combine those two. If I have 13x and someone adds 4 more to my pile, I now have 17 x's. Then we have a negative 11 plus 1. Well, negative 11 plus 1 should be a negative 10. So we have 17x minus 10. Now, before you do anything else, everything's simplified. We need to get every single x on one side. So I'm going to hold on to this 18x. I'm going to leave that here. But I don't want the 17x over here. How do I get rid of a positive 17x? We're going to do a negative 17x. And we're going to be careful because, 17x minus 17x, that cancels out. Be sure you line up your negative 17x below your other x's on your other side so you know what's being added. All right, 18x minus 17x, that's 1x. Minus 15 equals a negative 10. I'm going to move the 15 to the other side by adding 15 to both sides. So x equals 5. So for every one of these x's you see, you're going to replace it with 5. So instead of 4x plus 1, I have 4 times 5 plus 1. Well, 4 times 5 is 20, plus 1 is 21 degrees. Instead of 13x minus 11, we'll have 13 times 5 minus 11. Well, 13 times 5 is 65. Minus 11 is 54. Let me know if I make any mistakes in my head. 54 is good. And then instead of 18x minus 15, we're going to have 18 times 5 minus 15. Well, 18 times 5 is 90. Minus 15 should be 75. We go with 75? And to get this missing angle here, we can either use the linear pair with 75, or we can do the fact that I know two angles, 180 minus 54 minus 21. But either way, we should end up with 105 for that angle here. Now that I have everything noted, hey, I'd be okay if you just left this as your answer because you have everything listed, right? But if we want to fill it in here, we find CAB. Well, CAB, C-A-B, is going to be our 54 degrees. ABC, remember, we counted in order. A, B, C will be this angle here, 21 degrees.
I have a question.
Yeah.
Is
Only if you think there's a mistake.
15 for D over C? Oh, never mind.
You sure?
Yeah.
Yeah, if there's a mistake up there, let me know.
No, I think it's
Okay. ACB, that's going to be 105. Remember, they're just highlighting what angle we're talking about. That's that 105. And then we should have 75 for the last one.